Hi everyone! Today we're going to be going over the AP Chemistry FRQ Question 3 from 2015. Now, as you can see, there are 6 parts to this question, A through F, and we will be going over each one individually, so let's dive right into Part A. Now, as you can see, there are 2 equations written for Part A on the board. The second one having parts missing from it that are present in the first equation. The chlorine and hydrochloric acid on the left side of the equation is missing from the second equation, as well as the K from the potassium sorbate, also on the left side of the equation, and the first one is missing from the second one. On the right side of the equation, the combined molecule from those two are also missing from the second equation. And as you can see, this is the reaction actually happening. The instructions for Part B are as follows. A total of 29.95 milliliters of 1.25 hydrochloric acid is required to reach the equivalence point. Calculate, in brackets, potassium sorbate in the stock solution. Part B is mostly stoichiometry. Using the information given to us, we can set up a proportion to find the moles of hydrochloric acid. Our answer comes to 0.0374 moles of hydrochloric acid. Using this answer, we plug it in to complete the second part of the problem, or to calculate the potassium sorbate in the stock solution. Our answer for this comes to 0.832. For Part C, we are given the information that the pH at the equivalence point of the titration is measured to be 2.54. Our task for this part is to find which of the following indicators would be the best choice for determining the end point of the titration. From the chart written, we can see that thymol blue is the best choice for determining the end point of the titration. It has a pKa close to the pH at the equivalence point, so it will change color near the equivalence point. For Part D, we were told to calculate the pH at the half equivalence point. For this, it is one of the easiest steps in acid-base chemistry, and we will be using the Ka given to us in the initial instructions. For Part E, our job was to accurately sketch the titration curve on the graph below. As you can see, this is evidenced on the graph drawn on the board. Our instructions for the last and final part, Part F, are which species has a higher concentration in the soft drink. The stoichiometry element of this portion of the question is written on the board, and at this point would just be gathering the information already found in the problem and plugging it in to find one final answer. One other explanation for this last and final part would be the concentrations are equal at the half equivalence point. A pH of 3.37 is lower than that at the half equivalence point, so the pronated form has a higher concentration in the soft drink.